liquid nitrogen is 321 degrees below zero. Now we have 78% of the air we breathe is nitrogen. 21% of the air we breathe is oxygen. So which one do we need to live? Oxygen. Nitrogen doesn't react with anything, so therefore it's called inert. An inert gas is something that doesn't react with anything else.
Remember, this is 321 degrees below zero.
As you put your hand into it, it evaporates around your hand and creates a gas pocket. So now think of like a hot pan at home, and you put cold water on it and it sizzles, right? Your hand is the hot pan. This is the cold water. If I take some air and put it in a balloon, it came from my breath, so therefore it's going to have a lot more carbon dioxide in it than 0.04%. If I get it cold, if I have this equation right here, P equals P. Okay, now look at that equation. What happens if temperature goes down to pressure and volume? It goes down, okay? Pressure went down, and volume went down because temperature went down. Where's the heat coming from that I'm trying to heat up this other part, my hand? So I'm doing some heat transfer from my hand. And if I put some nitrogen in here, I'm going to demonstrate some heat transfer. We're going to keep it in this bowl though, so it stays nice and cold and it really doesn't evaporate very much. We're going to put that balloon on top, and I'm just going to hold it on there. You see it starts to blow up, but not very rapidly. Now if I take it out of here, it's going to start to blow up a little more rapidly. Now if I go put it in a water bath like this right here, let's put the nitrogen in here again. Now I want you to notice something. Is it floating? Yes, it floats. Therefore, which is less dense, the water or the nitrogen? The nitrogen is less dense. Okay, so when the bottle is tipped upside down, then the nitrogen goes to the back of the bottle, and the water covers the port. So if it covers the port, the pressure's got to go somewhere, and it pushes the water out. Now water has a structure that looks like this. It has an O and an H, two H's, and they're like this and they're bent. Then they can form a dotted bond, which is called a hydrogen bond, which is a very weak bond, with another water molecule. And it does the same thing over here. Okay? And then you end up with water. Now, the reason this is important is because as water gets colder, those hydrogen bonds become stronger. And it starts to look like this, in this hexagon shape. And then it starts branching out like that. And so the same thing with the ice cream mix. The ice cream mix has water in it, but it's got other stuff in it. And the other stuff in it is what causes the different shapes that form within the mix as it freezes. That's one of the reasons we use liquid nitrogen in the store to make ice cream. Because what happens is we freeze it this quickly. Not only do you get customization, you get a very fine water crystal product. And when we freeze it this way, the ice crystals get smaller than 8 microns. So that entire half gallon is completely frozen that fast. And that's what makes our ice cream. It makes it so that we can make the customization that you get with Sub-Zero.